Hey, welcome folks back to another video. So in my last video, which was about part one of the new ball and beam kit build, somebody asked me in a comment on that video if I could talk a little bit about my 3D modeling process, that kind of thing. So in that last video, I had talked a little bit about swapping over to using Fusion 360 as my CAD software of choice. And yeah, so they were asking a little bit about could I, demonstrate some CAD modeling and things like that. So I'm far from an expert, and I'm even further from an expert in Fusion 360 specifically, but I'm not an expert in CAD either. But I am able to leverage it to get what I need done. So what I said is, because I had to, at the end of that video, if you watched the last one, you'll know that I decided that I needed to redesign a bunch of parts and swap over from using a servo motor to using a little stepper motor and stuff. So I was going to have to rebuild a bunch of parts anyway. So I decided to remodel some and add in some extra tweaks that I noticed from playing around with the prototype. So with all that said, I started rebuilding it. I have my model almost finished here, but I have one part left to do, and it's a relatively simple part, but it has some kind of cool little features on it and stuff. So I thought this would be a good one to show you guys live. So I'm going to do that. I'm going to design it here in front of you, and you can see my process, and I'll talk through it as I go. And if you're not super interested in seeing that, I'll put a timestamp somewhere. You'll find it maybe here. Yeah, let's put a timestamp there, and you can skip on if you want to go ahead and watch the rest of this video. But I'm going to do a little bit of explanation here. Depending on how long this takes, I may cut it in places as well, or may fast forward bits. And if people really want, I can upload a full uncut version of it as well. So yeah, anyway, let's dive straight in. I might be a little bit interspersed with sporadic with my talking here, because as I actually think about what I'm doing, I may just be silent. So if that happens, I'll cut and do editing stuff anyway. So, but I'll try and make sure as I make decisions and as I call out things, I'll try and talk through what I'm doing the whole time. Okay, so this is my everything I have up to now. So the last piece that I've done that I have to do is the fulcrum piece, which will attach on here and will be a secure. So there'll be basically a little clevis here that this goes into. The pin will go through here in the real life version. Then the column of it will come down and meet some solid base here, and this is the main fulcrum that the whole thing hinges around. So I have some of this done up already with hinges and stuff, so you can see how this will move. It's not really constrained at the moment, so it can be a bit wild and crazy to move around. But effectively, once there's a pivot here and this end is fixed, you'll be able to fully kind of simulate all the joints moving around on it. Okay, so let's put that back. Yeah, okay. So what I'm going to do is, so the way I built this basically was I started with the motor mount, modeled that, then I modeled the little motor itself, which I didn't really have to do, but I did it just because of the motor shaft has a little key on it, so I wanted to have that modeled in. Then I modeled this linkage, then I modeled this linkage, then I modeled the beam. So now I'm going to start from the beam and work my way down and model the fulcrum piece. You could do this kind of anyway, any order really that you see fit. This is just kind of the way I thought through it in my head to just build it up incrementally bit by bit. Might not be the most efficient way to do it, but hey, it's just the way my head worked around solving the problem. Okay, so first thing we need to do is we need some references to work off of. So Fusion 360 lets you do a lot of cool things around making references really easily between existing parts, components, other components, and the new component that you want. So first thing we'll do, we're going to make a new component, create component. Ooh, where's that dialog? Oh God. Oh. Okay, I don't know what's going on there. There should have been a little dialogue that came up there, but it didn't come up. I have no idea why. I am doing some weird screen sharing stuff here, so I don't know if that's having an impact on how things are rendering. But anyway, we'll keep moving, see what happens. I can just rename this anyway. So call it the fulcrum. Okay, so I'm going to activate that as a main component, so this all gets grayed out. Now, what we want to do, the first thing we need our reference plane to work off of. So we're going to create that. And it should be pretty easy to do. So what we'll do is we'll go to our construct, and we're going to define an axis. So the axis I want is going to be around this here. So we see we have our axis created there. Create that. Then I can select this axis, and now I can construct a plane at an angle. I'm going to say it's at a 90-degree angle, so it's vertical. Cool, that works. And we will go with that. And then I can move around and select this plane. And we're going to do another plane off of that one, which will be an offset plane. And effectively, what I'm doing here is, because I want to start my, here, and I want to make an extrusion that is basically the clevis piece to come out this way from it. So I'm going to, this plane is through the very center of that axis. So if I want it to be centered, I want this to be 20 mils thick. So I'm going to push this plane back by minus 10 mils. So there we go. So that'll start there. So hit enter there. Now I can hide some of these planes, which I don't really care about anymore. So I just want this plane. So select this plane, and we're going to do a sketch on this plane. So this can be a little bit tricky to see what's going on here now because of all these other bits of geometry. But I can hide the bits that are gonna mess up. Yeah, so this is a bit easier to see now. This is just the back end of the beam we're looking at now. And this is specifically the little part where the joint will go through that we want to make the clevis either side of it. So I'm going to start off just with drawing some lines, and then I will draw the lines, and then I'll dimension them afterwards so that they are so they kind of match everything up correctly. So start off basically straight line across here, come down below here, across here, and we'll go up, and we'll go across, and we'll go down, across, and up again. Okay, so now we can start dimensioning this and putting in our different constraints that will help us set up our alignments, that kind of thing. So I'm going to draw some construction lines, the way you make that. So basically any geometry can be made a construction geometry by selecting the tool and then pressing the X key on your keyboard. And now you'll see it'll get drawn as a dotted line, which means it's for construction purposes only. So you can't select that as part of when you're doing your extrusions and stuff later. You won't be able to select that geometry. It just makes it a bit easier to see as well what's going on. Okay, what else? Okay, yeah, another. Make this a vertical line, and then yeah, I have this origin here, so I think I can. Is that the origin? No, it's not. That's that axis. Okay. So what I need to do is I need to start making dimensions around this other piece here. So now this is where things aren't maybe ideal. Ideally, you should do this all with sort of references between other things. I'm not doing that. I'm being kind of lazy and just throwing in dimensions willy-nilly. Oh, what's happening? Kind of willy-nilly to references between other models and stuff. Ideally, what you're supposed to do is you're supposed to make like reference planes for everything and make sure the dimensions match up. I'm just clicking on any random points and trying to match it all up, which does work, but you can get yourself into trouble with it. This is a sufficiently simple part that I'm not too worried about that. Anyway, what was I doing? Okay, yeah, so let's get some symmetry here. So select 2 points. I'm saying they're symmetrical about, oh damn it, I can't select the origin there, damn it. Never mind that. We'll just do it with a dimension instead. What way would we do this? Okay. So the distance between these two, I believe I want it to be 7 because I think this piece is 5 mils and I want 1 mil either side. So yeah, I'll make it 7 mils. And now obviously I need this from here to there. I want to be 1 millimeter. There we go. Now the thickness of this is supposed to be 5 mils, I think. Or actually, will it be 5 mils? No, it won't be 5 mils. I'm not going to define it that way. I want to define the overall thickness of it, which is going to be 20 mils. So select the two outside points, make that 20 mils. Okay, yeah, but that's just added onto that side, so I need to make them the same. Okay, so I'm gonna actually do here, I'm gonna make a midpoint like that. Yep, damn it. That was supposed to be a construction line, and I made it not a construction line. All right, try again. There we go. Okay. So now I'm going to use our symmetry tool and say this point are symmetric about that line. There we go. Okay, what else have I got in here? So yeah, a lot of the rest of these dimensions are kind of arbitrary. The depth of this clevis doesn't matter a huge amount. Obviously, the deeper that clevis is, the more the arm will be able to swing down the way. It doesn't need to swing through a huge angle. You can see here, this is the bottom of it. So I'm just going to see what that dimension is. And often a trick that I do for this sort of stuff is I just kind of look at, what is it roughly? So that says it's 3.07 mils. So let's just make it 3 mils. Yeah, we'll see what happens. I can test it when we have the piece made, see how it moves around the place. And yeah, we'll see what happens then, see if we have enough clearance and stuff. So what else have we got? Okay, yeah, so the only other bit that's unconstrained now is this. Yeah, so that can be moved, that can move up and down. Now, I suppose, yeah, actually, I can do this. So at this point now, I can pretty much make this all the way down nearly to the ground plane, except that I want to have a separate pad on the very bottom of it, which I want to be 5 mils thick because that matches the other one. So I actually just kind of need to line it up, and I can just drag this down more or less to exactly the same. So I'm going to do is going to add back in the motor mount piece. There we go. So effectively what I'm going to do is I'm going to drag this line down until it matches with that. There you go. That's pretty much it. So, but I'll do that properly with a constraint. So I can select that point and I can say that it's going to be coincident with that line. There we go. So that's, yeah, that's most of this done. It's pretty much the entire part done, actually. Like the bulk of all the referential geometry that's really important for how this all hangs together is all done now completely with this. Okay, so that part is, that sketch is fully constrained, so I can exit out of that now. And you see here, the only shape that I can select is what was bounded by all of the solid lines, and I can't select anything that was bounded by these dotted lines. So I'm going to select this. I'm going to go up here to our extrusion tool, and we're going to make an extrusion. This is going to be a new body, and I'm going to want it to be 20 mils thick. So I put in 20 mils. Now, if I rotate around, you can see that that is what it's going to look like when it gets extruded, which is lovely. So looking at it there, it almost doesn't need to be 20 mils though. There's a lot of clearance there. So I might take that, let's reduce that. Okay. Or do I want it to stay 20 mils? This is always the doubt about, you know, debating about the thicknesses of things. I always find is about, you know, whether do I want, if I take a few mils off it, will it just be a little bit less strong than it was? I mean, probably won't be. Let's just leave it as 20 mils for now. Okay, there you go. Wonderful. Okay, next piece I want to do is I want to do the through hole, excuse me, which is what it can pivot around. And then I can add some fillets to the top here. Then I'm going to add a little base to it. And then I'm also going to add some ribs off the sides of it, which will be for support. But I'll show you once I have the ribs done, because it'll be easier to see. And then also once I have the through hole done, you'll be able to see I can freeze all the parts properly and get the moving geometry back up and running. So let's do that. Okay, so we're going to do sketch on this face. Oh, okay. And pretty much all we're going to do is just draw a circle. We just have to correctly position that circle. So go like this. And it's just 2 dimensions, 3 dimensions really. So from there to there, that should be 7.5, I think. Is that right? Yeah, 7.5. And then from here to here should be 10 millimeters. 10 millimeters. And now the diameter of that should be 5.5. So 5.5, I just know that's the diameter that I've been making all the through holes, so that it's basically nominally sized so that it'll fit an M5 bolt through it with a small bit of slop in it so that things can move around, and also taking into account the 3D printing tolerances. The 7.5 is, and you can see that there nicely, because so that curve that's just highlighted there, that is the backside of the little slot that it's going into. So I know that that's lined up nicely because it's centered on, I made it a radius of 7.5 all around. And then 10 mils is the center of this because it's 20 mils wide. So that's all simple. Now let's cut our hole in it. So there's a lot of different ways you can do holes in FreeCAD. Excuse me. You can do them using the holes tool, which is here. I'm not going to do that because it's kind of specific thing as the way you use that. I'm going to use the extrusion tool to do it instead. I'm not going to get into why there's a difference, but there is a difference in how you can use them, why you would use them. Anyway, so we'll select this sketch geometry, go to our extrusion, and now what we want to select for the extrusion is that it's going to be an extruded cut. And now if we move around, you can see the direction of the cut is going to come that way because it's based on the planar face. So we're going to make it go in the negative direction. So I think it's 20 mils, so I want to go minus 20. So yeah, it's going to go back the way. And the objects to cut, it's just cutting through the fulcrum object. So it highlights this object for you, I think, because the geometry goes through it, but it's not actually going to cut it. And if it would intersect with other objects, you can deselect them here to make sure you don't go cutting holes into random objects. And that should put a hole straight through that. Yep. So do that. There we go. Next thing, let's add some fillets up here just to make it look a bit pretty. So I select those 4 corners, go up to modify here to the fillet tool. And because it's 20 mils, I can do 10 mil fillets. Yeah, there we just get a nice rounded top on it. Click OK, and that's done. So with that done now, we can actually simulate the entire movement of the rig by creating, I need to create a new join in here, a new joint in here basically. So what I do is I'll click on the joint tab here in the assembly, and it highlights all of the parts. So now I have to go in and find my geometries that I want to join. So I'm going to select these 2 circles there and there. Yep. And so there you go. You can see it's where it's put it in. I'm going to stick in the offset because you can see that's basically putting them hard up against each other, but I actually want a slight offset. So I think this is going to be -1, yeah, in the Z direction. There we go, and there we have it. So now to simulate this, make sure it moves in all the correct ways. What you can do is I'm going to select the fulcrum piece. I'm going to click ground, which means that it's a solid piece that won't move around. I'll expose all these bits, yeah, and I'll select this so you can see everything. And now effectively I've said the motor mount, and the fulcrum are all fixed in place so they can't move, but my other ones, my lower linkage, my upper linkage, and the beam are all free to move around the joints that I've created. Each of these joints are basically a free rotation joint that I've set up with concentric circles, so they're basically just like pivot points around pins. So if we set up a nice front view, let's see what happens. And, oh, what did I do there? I did something I didn't like there. Oh, okay. So I set up a front view, and now there we go. That's how our beam will move now. Nice. So as the motor shaft rotates, the shaft will be locked onto this pivot point, and then that linkage pushes the beam up, and then also can bring the beam down like that. And there's the angle that we move through. And so you can kind of zoom in on your points, which is cool. So you can see all your clearances and see where things start to touch each other. So for here, I can push it and see if we get any collisions between any of these parts, which I'm pretty happy there we don't, which is nice. Obviously, if I... Oh yeah, we don't actually get any at all. That is quite nice. Well done me. I thought I would get a collision somewhere there, but it seems though I won't apparently, which is cool. Nice. Okay, well, it's not supposed to move that way. Come on, move back up. There we go. And yeah, so then that will move up, move down. There's nothing that will get in the way there. Yep, doesn't move it anywhere it's not supposed to. And then on the back side over here, which I was a little bit concerned about, zoom in a bit here, you can see, yeah, so there's no, well, it will bottom out eventually there, but I think, yeah, it's hopefully will not end up in that position anyway, so it shouldn't really be too much of an issue. Whoa. Yeah, so if I put that to, that's probably about where that bottom position will end up. It's not hitting there, and then the same when I go up the way, it doesn't hit either. So yeah, nice, that's it. I'm gonna kind of leave it there. There is a little bit more to do on this part, but it's just basically putting a flat base on this and then also sticking some ribs off the side of it. It's not going to be hugely interesting. I think this is probably more interesting to have seen how I put that together and how I use this tool to check all my clearances and stuff there. This was done based off a prototype, so I already had some dimensions and things like that and some physical, pieces here that I could take measurements off of. So it's not a full from scratch build of this, but it's still really good to be able to set this up quickly to validate that all my joints do work the way I want them to. Quick note as well, this beam is also about 5 or 6 centimeters longer. The ball's travel path is, which is really, really good. So we'll be able to, actually I think it's way more than that actually. It's a bit longer. What is it? So this is, yeah, it's actually 7 centimeters longer of the travel path, so should be a little bit more interesting to work with, and it should actually be a little bit easier to get it to balance as well. You have more room to move, and it can actually move through a little bit of a better angle than the last one did, so that's good. Okay, so that's it for this overview. I hope you guys enjoyed that. I hope it was useful. But anyway, in real life, Ian now has to go and finish this design. He has to print all these parts, he has to assemble it, and he has to start tuning the PID controller. So hopefully that's the next part you see, is the PID controller being tuned up and working nicely for a little demonstration of the, hopefully what is maybe V1 of this that actually works. Okay, so let's do that, and I will see you guys then. Okay, we're back, and I've got a rudimentary tuning on the rig, and as you can see, it's moving around, it's trying to do some things, but it is actually balancing the ball and not doing a terribly bad job at it. It's a little slow, but it does get there for a very first pass kind of rudimentary tuning on the PID. There we go, sits back into the center again, so that's reasonably good. I don't think it's amazing, but it does work. There's a little bit of noise that I'm noticing when it's sitting at its set point. It sort of wants to jitter a little bit. It's also when it gets very close to the set point, sometimes it'll just
it's very close but not quite there, and it'll sort of vibrate a little bit to try and move it, and then I can introduce another kind of oscillation into it, which will then kick off into bigger oscillations until it dampens back down again. But if I give it a flick, it detects that movement and it starts trying to counteract it. That's what I meant there about the little got stuck, and then it's going to come back. Oh, very close there, very close. See now, yeah, it's kind of stuck there, but yeah, it's kicked itself off again. And let's see, and there we go, back to the set point. So that's working pretty well. And there's a little drift there. So also this, I haven't got this set perfectly level, so it's not balancing it. The idea is that it obviously needs to balance it, but also the beam needs to be level as well, so that it won't, at some point, if it's just ever so slightly off, something will cause, the friction to be overcome. Gravity will overcome friction and it'll start rolling again, which obviously we don't want. So it's not perfect, but it does more or less do the job. So I'm confident that it works. And with some extra tuning and some more messing around, I should be able to make this even better. So there we go. That's sitting there doing the exact thing that it's meant to be doing, and it's quite quiet as well. So that's nice. So yeah, more work to do, but essentially this is, I think, basically what this prototype will be. Obviously you have to fix up all the electronics. This is all just on a breadboard, so there's a hell of a lot more work to do, but functionally the thing works, and I'm pretty certain this will be what all the pieces look like for the first version of this. All these parts went together really nicely, they cleaned up really nicely, everything fits quite well, so I'm pretty happy with all that. So the next steps, I'm not entirely certain what the next steps are going to be on this. I'm going to unplug this just because of the noise. Yeah, next steps, there's a lot to do. What I will probably do is I'll probably spend some time tuning up on this a little bit better. I might tweak the code a little bit to see if I can improve how it performs, and then I might go and I might redesign the electronics a bit. There's also, I want to make this a little bit more configurable. So at the moment the motor is running in 32 step mode. I'm basically maxed out on speed, so I want to be able to make it configurable so that within the code you can change the amount of microstepping and stuff like that, and mess with the speed parameters a bit so that you can maybe tune this up differently yourself. So I'm going to play around with that, make the code and the basically the wiring support all that, and there's a couple of other little tweaks that I want to make. The next big thing then, I think what I want to do after that is I might design a PCB for this. I've never actually, well, I have designed a PCB, I shouldn't say I've never done it. I have done it more like 10 years ago. So I might take a stab, design the PCB, and see if I can get that made as well. That'll be kind of a cool thing to have for this. And of course I'd make those plans available as part of the kit, and then if the a fully manufactured kit would come with that PCB then for it. So yeah, a lot to do, lots done, still lots more to do, but yeah, I think I'm going to leave that here for now, and I will catch you guys next time. See you later.